Alright, so in this video we're gonna run a hypothesis testing test using a TI-84, and the test will be a t-test. So we are having a mean of 50.07. however we want to verify it, and we are tested 10 entries over here, and we want to test it at the level of 0.05 level of significance. And the claim here can be concluded that the average phone bill has increased. And let's start with the first statement, A. So the phone bill has increased. It means the mean is greater than the average, which is 50.07. what's supposed to be, right? Now this is strict inequality because has increased means greater than, there is no equal sign, and this will be the alternative hypothesis and the claim as well, one-tailed, and the alternate, and the 80 will be then the mean equals to 50.07. So now if I have a 0 here and I want to graph this statement, that's what I should do. It's going to be on the right side, and this is going to be your alpha, totality of the alpha 0.05, and we are all set with the A. Now for B, we are looking for the critical value. So in order to get the critical value, you need two things: a degree of freedom, which is n-1, and you need the alpha, which is 0.05. so this is n-1, you're going to be 10 minus 1, which is 9. And then what you need to do, you need to use the t-table. All right, so let's get there. For the t-table, we can follow here the one tail, 0.05 right there. So we are following this column, and then degree of freedom is 9, and we extend it all the way to this column, and the intersection would be this number here, which is 1.833. so this is going to be your T critical, 1.833. So what the meaning of this? It means that the point where the alpha is going to stop here is 1.833, and that will be the threshold between accept and reject. So if I extend this is going to be reject 80, here fail to reject, or do not reject 80. All right, so we are ready for D. And for C, we are looking to compute the test value or the p interval. All right, this is easier done by the calculator. So what you need to do is to go to stat, go to tests, and then go to t-test. That's the second one. You have only one sample, enter, and you have two options: either the data option, that's in case you want to enter the whole numbers in a list, which we are not going to do, and we're going to use these two values that they gave to us, right? The x bar here and the s here. It saves us some time. So let's go to stats, and for stats they're gonna ask you for mu0, and mu0, that's basically 50.07. So I'm gonna type it in, 50.07. Now the x bar is 56.11, 56.11. The sx is 6.97, 6.97. The n is 10, and here you're gonna just write your claim, or HA. So the mean greater, so greater, you're gonna go right here, then mu0, enter, and then you're gonna go to calculate. All set. All right, so what we get here, that the t-test equals to 2.74, and as well we have the p-value, and that will be 0.0114. okay, that's C. D, we want to make a division, so the decision is either you compare the t-test with the t-critical, or either you compare the p-value with the alpha. So the p-value and the alpha, the formula is, if the p-value is less than the alpha, you reject 80. So this is my formula. Now let's identify the p-value, which is 0.0114. The alpha value is 0.05. So this is true statement, correct? And here we're gonna reject 80. Okay. In other words, if I place the t-test on the graph, it's gonna fall somewhere here. This is 2.7, and this is the t-critical. So you see, is within the reject A0. So the conclusion, so E, the conclusion, we rejected A0. So we have enough evidence to support the claim, which is, the claim by the way is HA. To relate it to the problem, yes, we have enough proof that the average has increased. And that's all.